Hello everyone. About 10 years ago I'd written a paper that showed why matter can travel and does travel faster than the speed of light. A website out of Texas called KeelyNet asked me for permission to publish, and I gave them permission to publish my paper. Over the last year or so, and that would have been sometime around 9 years ago, 10 years ago, somewhere in there. Anyway, over the last year, KeelyNet and my paper have just disappeared off the internet. So, shortly after I copyrighted my paper, I was sitting in a bar. Sitting in a bar is how most of my good stories start. And anyway, sitting next to me just happened to be an associate professor of physics from Dalhousie University. And I got him interested in my explanation of Einstein's famous equation, E equals mc squared. So I explained it to him in practical terms and what the meaning was of the famous equation. And here's what I told him. Let's pretend, keeping in the bar theme, let's pretend that this bottle of tequila is a nucleus of an atom. And this shot glass is an electron that's going around the nucleus. Now, it's traveling around the nucleus at about the speed of light, although we don't know for sure because nobody has ever been able to measure the speed of an orbital electron. Electrons have been measured linearly, but not orbitally. So anyway, let's assume that it's going around at just sublight speed, but close to the speed of light. Now, if you move this whole atom at the speed of light, as this electron is coming forward, it's traveling at the speed of light squared. So when that happens, the electron is stripped away and the energy that was keeping it there is released. That's what E equals mc squared means in practical terms. So after I explained this to the associate professor, he said something to the effect that, that's amazing. He says, I never understood the equation in practical terms. Where did you get your physics education? So I told him that I had my OGT. Well, he said he wasn't familiar with OGT, so I explained to him that it was only grade 12. After I told him that, I laughed and he totally dismissed me. I guess probably just as some drunk in a bar who didn't know what he was talking about, especially because I didn't have a degree in physics. Anyway, imagine my surprise when I'm watching TV about, well, a few months later, and I see this same associate professor of physics from Dalhousie University explaining what I had taught him with regard to the electron traveling around the nucleus and coming off when the whole thing is traveling at the speed of light. And he claimed the explanation as his own. So, since my paper had already been copyrighted prior to that and was published, I let it slide. But now, since my paper is no longer on KeelyNet, I'm here to give the full explanation of my equations. And here's what they are. E equals mc squared, then in brackets AER. AE is the effective area of a magnetic field, R is resistance. So let me explain that to you. When I looked at why this whole atom is traveling faster than the speed of light. I said, why? Why does that happen? And the only thing that I could think of that affects an electron would be either another electron knocking into it or a magnetic field. I mean, how do we create electricity? We use a magnetic field to move electrons. So I said, okay, if that's happening, if this is coming off when it travels up to the speed of light and this comes off, then it's got to be stripping it off. A magnetic field has to be stripping off that electron. So, AE, the effective area of a magnetic field, and R, resistance. So that the resistance, of course, is the resistance of the magnetic field against that electron traveling at close to the speed of light. When that happens, it strips it off. Now, then it occurred to me, well, what happens if the magnetic field moves with the matter? E is not equal to mc squared AeV. AE again, effective area of the magnetic field, V, velocity. So energy is not created if the matter is moving at the speed of light squared, but the magnetic field is traveling at the same velocity as the matter. Now, let me explain that to you. If the magnetic field is moving with the matter, then the electron relates to that magnetic field the same way that a fly in a car relates to its environment. A fly can't fly at 100 miles an hour, but if he's in a car and the car is traveling at 100 miles an hour, and he's flying from the back of the car to the front of the car inside the car, then he's actually flying faster than 100 miles an hour. So, if you move the magnetic field with the matter, then the electron relates to that magnetic field because the resistance isn't there that it would have if it was traveling through that magnetic field. So that means that if you have a strong enough magnetic field around matter, you will be able to travel faster, that matter will be able to travel faster than the speed of light. So the biggest arguments that I've had about that from various professors is that, no, that can't be, because magnetism, light is an electromagnetic wave, and therefore magnetism can't travel faster than itself. And I referred them to a paper that was written by a fellow out of Northern Europe several years back, where he explains that the shortest energetic wave is a gamma wave, and the longest light photon is only 40% of the length of a gamma wave. Now you can see a single light photon, but there is no such thing in nature as part of a wave. You either have a wave or you don't have a wave. So that explained it. That wasn't good enough. That went over their heads. So I pulled out I said to them, is magnetism affected by glass? They said, no, of course it's not. Is magnetism affected by water? Or in this case, tequila? No, of course not. I said, okay, but if I put this rather straight knife, give or take, into this glass of tequila or water, does it look straight or does it look bent? It looks bent. Now, if light was a magnetic wave of any type, it would not be affected by the glass, and it would not be affected by the tequila water. And so the knife would look straight, it would not look bent. So that pretty well explains it. If you have any questions, I love your comments, and I hope you enjoyed this video. Thanks for watching.